A week later, we found that Messenger had been blocked again, but this time it was different. The AOL server was sending a huge chunk of new gobbledygook that I could not understand. It looked approximately like this. Here is a message that is a very long sequence of two-digit numbers, hundreds. None of these numbers mean anything when translated into alphanumeric characters. The most remarkable thing is that the majority of these numbers in the middle of the message are zero, and so can't be conveying very much information. The first couple of lines are the standard AOL Instant Message Protocol header, but less than a quarter of the way in, it becomes incomprehensible, bearing no relation to anything the AOL servers had sent their client or ours. The vast expanse of double zeros in the middle was also mysterious, since a bunch of zeros couldn't contain much meaning. Our client ignored it, but the AOL client responded to this gobbledygook with a shorter version of the same gobbledygook. I didn't know what it was. It was maddening. After staring at it for half a day, I went over to Jonathan, a brilliant server engineer on our team, and asked what he thought. He looked at it for a few minutes and said, "This is code." It was actual x86 assembly code. The repeated 90s tipped him off. They signify a no-op, no-operation instruction in x86 assembler, telling the processor to do nothing for one cycle. The pieces then came together. Normally, protocol messages sent from the server to the client are read as data, not as code. But AOL's client had a security bug in it, called a buffer overflow. A buffer is a place in memory where a program temporarily stores data during execution. It's all too easy in lower-level languages to allow in more input than the buffer can accommodate. In this case, large protocol messages flooded over the end of the buffer. In the computer's memory, the locations past the end of the buffer are often filled with things that aren't just stored data. The actual assembly code to be executed is often nearby. This buffer overrun could overwrite the client code currently being executed and control the functioning of AOL's program. It's a huge security hole, since it gives the server control of the client PC. In the wrong hands, the server can shut down or spy on a computer. AOL knew about this bug in their program, and now they were exploiting it. The double zeros were filling up space in the program's buffer, so that once the large message hit the end of the AOL client's buffer, it would overwrite executable code with the remainder of the protocol message. The remainder of the protocol message contained new code to be executed, which the client promptly did. AOL caused the user's client to look up a particular address in memory and send it back to the server. This was tricky, vastly trickier than anything they'd done so far. It was also a bit outside the realm of fair play, hacking into their own client using an unfixed security hole, a hole our client didn't possess. A "Rommel, you magnificent bastard" moment. I was out of my depth. Someone else at Microsoft, I never found out who, told the press about the buffer overflow, figuring that if people knew that AOL's client had a huge security hole in it, AOL would be forced to patch their client and would no longer be able to exploit it. According to security expert Richard M. Smith, a certain Phil Bucking of Bucking Consulting sent him a message, alerting him to the buffer overflow in the AOL client. Mr. Smith: I am a developer who has been working on a revolutionary new instant messaging client that should be released later this year. Because of that, I have followed with interest the battle between AOL and Microsoft and have been trying to understand exactly what AOL is doing to block MS and how MS is getting around the blocks, etc. Up until very recently, it's been pretty standard stuff, but now I fear AOL has gone too far. It appears that the AIM client has a buffer overflow bug. By itself, this might not be the